Essential truth number two, AI reflects human values, which means we control its impact. How human values shape AI. The influence of cultural norms. In 2016, Microsoft launched Caah, a chatbot designed to learn from conversations with Twitter users. Within 16 hours, the bot began posting racist and inflammatory messages. Microsoft shut it down immediately, but the damage revealed something fundamental. AI systems absorb and amplify the values embedded in their training data, which means they reflect the cultural environment of their creators. This wasn't a technical failure. The code worked exactly as designed. Cultural norms shape every stage of AI development, from the data scientists select to the problems they prioritize. For instance, the groundbreaking Gender Shades project by Joy Bolamwini and Timnit Gebru demonstrated how facial recognition systems struggled to accurately identify darker skin tones, especially those of women, due to training datasets predominantly featuring lighter-skinned faces. Their research, published in 2018, found error rates for identifying light-skinned men were less than 1%, but for darker-skinned women, error rates could exceed 34%. The engineers didn't intentionally build a biased system. They built one that mirrored the limited perspectives within their development environment. Bolamwini and Gebru, 2018. These oversights happen when teams lack diversity, when certain communities are underrepresented in the rooms where decisions are made, and when cultural assumptions go unexamined. Consider how language translation AI handles gendered professions. Early systems routinely translated doctor as male and nurse as female across multiple languages, regardless of the actual text. The algorithms learned these associations from billions of text samples that reflected historical gender imbalances. The AI didn't invent sexism. It learned patterns from a world where those stereotypes already existed. What makes this both troubling and hopeful is the same truth. Humans remain at the center of the process. We choose what data to use, which outcomes to optimize, and how to test for fairness across different populations. When development teams actively seek diverse perspectives and challenge their own assumptions, AI systems become more equitable. When they don't, the technology perpetuates existing inequalities. The question isn't whether AI reflects human values. It always does. Ethical considerations in AI design. Ethical frameworks are the structured systems of principles that guide moral decision-making in technology design. For AI, these frameworks don't emerge from algorithms themselves. They're deliberately chosen by the people building the systems. When engineers at Google debated the ethical implications of Project Maven, a contract to use AI for military drone analysis, leading to widespread employee protest, they were applying ethical frameworks to real technical choices. When researchers at OpenAI implement rigorous red teaming exercises and release detailed safety guidelines before deploying advanced language models, they're making moral choices about how technology should serve humanity. The most common frameworks in AI development include consequentialism, which evaluates actions based on their outcomes; deontology, which emphasizes duty and rules regardless of consequences; and virtue ethics, which focuses on the character and intentions of decision-makers. A consequentialist approach might approve facial recognition technology if it reduces crime, while a deontologist might reject it based on privacy rights, even if the outcomes seem beneficial. Neither perspective is inherently wrong, but the choice between them fundamentally shapes what gets built. When autonomous vehicles are programmed to handle unavoidable accidents, engineers must encode specific moral priorities. Should the car protect passengers or pedestrians, favor younger lives over older ones, minimize total harm, or protect the vehicle's occupants? The famous MIT moral machine experiment collected 40 million decisions from millions of people worldwide and found profound cultural differences in these preferences. Germans and French respondents were more likely to spare pedestrians. Chinese and Japanese respondents prioritized saving more lives, regardless of who they were. Awad et al., 2018. Every self-driving car embeds someone's answer to these questions. Transparency means making AI decision processes visible and understandable to those affected by them. Accountability means establishing clear responsibility when systems cause harm. These principles matter because AI increasingly makes consequential decisions about loan approvals, job applications, and parole recommendations. When a bank denies your mortgage based on an algorithmic assessment, you deserve to know why, and someone needs to be responsible if that decision was unfair. The challenge is that many powerful AI systems function as black boxes, producing accurate predictions without explaining their reasoning. Developers face a genuine tension between performance and interpretability, between building systems that work well and systems we fully understand. Human oversight and regulation. Regulatory oversight isn't an abstract bureaucratic concept. It's the difference between AI systems that serve you and those that exploit you. Without meaningful governance, the ethical frameworks discussed earlier remain voluntary suggestions rather than enforceable standards. When the European Union passed the General Data Protection Regulation in 2018, requiring companies to explain automated decisions affecting individuals, it wasn't merely symbolic. Companies scrambled to redesign systems, hire compliance officers, and build transparency into processes they'd previously kept opaque. Regulation changed what was technically and economically viable overnight. Your stake in this goes beyond principle. AI already determines whether you qualify for credit, what medical treatments insurers will cover, and which job applications receive human review. The Equal Employment Opportunity Commission reported that as many as 83% of employers use automated systems to screen job candidates. Yet most applicants never know an algorithm rejected them. EEOC 2023. Without regulatory guardrails requiring transparency and appeal mechanisms, you have no recourse when these systems make mistakes, and they do make mistakes. Effective governance requires both carrots and sticks. The National Institute of Standards and Technology recently released voluntary AI risk management guidelines that help organizations identify potential harms before deployment. Some companies adopt them willingly. Others won't without legal requirements. California's Assembly Bill 2930, for instance, would mandate impact assessments for high-risk automated decision tools in employment. These aren't burdens on innovation. They're the same kind of safety engineering we expect for bridges, pharmaceuticals, and aircraft. You have more influence here than you might assume. When constituents contact elected representatives about AI regulation, policy follows. The explosion of state-level AI legislation, with nearly 200 bills introduced in 2023 alone, reflects growing public demand for accountability. Smith et al., 2023. Professional associations, community organizations, and civic groups increasingly advocate for specific governance measures. Your voice matters, because regulators often lack technical expertise and rely on public input to understand real-world impacts. The systems being designed today will shape opportunities available to your grandchildren. Recognizing and mitigating bias in AI. Identifying bias in AI systems. Bias enters AI systems through two primary pathways: the data used to train them and the algorithms that process that data. Both routes matter, though data quality problems tend to be more common and harder to detect. Training data bias occurs when the information fed into an AI system doesn't accurately represent the population it will serve. Consider a hiring algorithm trained on 10 years of resumes from a tech company that predominantly hired men during that period. The system learns to associate successful candidates with male-coded patterns, not because it was programmed to discriminate, but because it found correlations in historical data. Amazon discovered this exact problem in 2018 when their experimental recruiting tool systematically downranked resumes containing the word women's, as in women's chess club captain. The algorithm wasn't malfunctioning, it was faithfully learning from biased historical patterns. Daston, 2018. Healthcare datasets frequently suffer from similar representation gaps. If a diagnostic AI trains primarily on data from urban teaching hospitals, it may perform poorly when deployed in rural clinics, serving different populations with different health profiles. The algorithm has never encountered certain presentations of disease, certain genetic variations, or certain environmental factors that affect diagnosis. Algorithmic bias emerges from how systems are designed to weigh factors and make decisions. Even with perfect data, the choices programmers make about which variables to prioritize can introduce unfairness. A credit scoring algorithm might use zip code as a proxy for risk, which sounds neutral until you recognize that residential segregation makes zip codes correlate strongly with race. The algorithm never sees race directly, yet produces racially disparate outcomes through seemingly innocent variables. Recognizing these biases requires asking specific questions about any AI system you encounter. Who created the training dataset, and who did they include or exclude? What correlations might exist in historical data that shouldn't guide future decisions? Which factors does the algorithm consider, and could any serve as proxies for protected characteristics? You can start noticing these patterns in everyday technology. When your photo app struggles to recognize faces with darker skin tones, that's training data bias. When translation tools assume doctors are male, that's learned correlation. When recommendation algorithms show you increasingly extreme content, that's algorithmic design prioritizing engagement over balance. These aren't hypothetical concerns reserved for specialists to worry about. They're patterns you can learn to spot in the AI tools you encounter daily, giving you the power to question and evaluate the technology shaping your world. Consequences of biased AI. Bias in AI doesn't exist in isolation. It ripples outward, touching lives in ways that might seem invisible at first. When an AI system makes biased decisions, it can deepen existing inequalities and create new forms of injustice. Think about hiring algorithms that favor certain names or backgrounds, effectively screening out qualified candidates before a human ever sees their application. Or consider facial recognition systems that struggle to accurately identify people with darker skin tones, leading to misidentification and wrongful accusations. These aren't hypothetical scenarios. They've happened, and they've caused real harm to real people. The social consequences extend beyond individual cases. When AI systems used in healthcare prioritize certain demographics over others, entire communities may receive inferior care. When loan approval algorithms systematically deny applications from specific neighborhoods, they reinforce historical patterns of economic exclusion. These automated decisions carry the weight of seeming objectivity. After all, a computer made the call. But that appearance of neutrality can actually make bias more insidious. People may be less likely to question or appeal decisions that appear to come from impartial technology, even when those decisions reflect deeply flawed assumptions embedded in the system. Understanding these implications matters because awareness is the first step toward change. When we recognize how biased AI can perpetuate injustice, we're better positioned to demand accountability, advocate for fairer systems, and support efforts to build AI that genuinely serves all of humanity, not just a privileged few. Strategies for mitigating bias. Diverse data sourcing stands as one of the most practical tools we have. Training datasets need to include faces of all skin tones, voices with varied accents, examples from multiple cultural contexts. Research by Boulamwini and Gebru, 2018, revealed that commercial facial recognition systems showed significantly higher error rates for darker-skinned women compared to lighter-skinned men, primarily because training data underrepresented these groups. Simply adding more data, though, doesn't automatically solve the problem. If historical lending records contain decades of discriminatory practices, feeding that history into an algorithm will only amplify existing patterns. The data needs to be diverse and representative of fair outcomes, not just reflections of how things have always been done. Boulamwini and Gebru, 2018. Algorithmic transparency opens another pathway forward. When developers document how their systems reach decisions, auditors can pinpoint where bias creeps into the process. The EU's General Data Protection Regulation includes provisions requiring companies to explain automated decisions that significantly affect individuals, Regulation EU 2016/679 2016, creating accountability that didn't previously exist. Transparency has its limits, however. Modern neural networks can involve thousands of layers, making it nearly impossible to trace exactly why a system chose one outcome over another, even for the people who built it. That's where human oversight becomes essential. Keeping people involved in high-stakes decisions, loan approvals, medical diagnoses, sentencing recommendations, provides a critical safeguard. It means establishing review processes where affected individuals can challenge AI-generated outcomes. Yet human oversight can fail when reviewers grow complacent, trusting the system without genuine scrutiny. Research on automation bias shows that people often defer to algorithmic suggestions even when those suggestions contradict their own judgment. Perpetuate and Manzi, 2010. These approaches work best in combination, but they demand sustained attention. A hiring algorithm audited and corrected today may develop new biases within a few years as underlying data shifts and the job market evolves. Bias mitigation isn't a one-time fix. It's an ongoing commitment requiring resources, expertise, and willingness to acknowledge when systems fall short. Real-world examples of bias mitigation. Some of the most encouraging progress in AI has come from organizations that decided to confront bias head-on, rather than hope it would simply disappear. Consider the case of a major healthcare provider that discovered its AI diagnostic tool was consistently underperforming for patients from certain ethnic backgrounds. Instead of downplaying the problem or blaming the technology, the leadership team paused deployment, assembled a diverse working group, and systematically rebuilt their training data to include representative samples across all patient populations. Within 18 months, the revised system achieved equal accuracy across demographic groups, and the organization published their findings openly so others could learn from their approach. What made this effort successful? Transparency played a crucial role. The organization acknowledged the problem publicly, which built trust with both patients and the broader medical community. They also committed to ongoing monitoring, establishing review processes to catch emerging bias patterns before they could cause harm. Perhaps most importantly, they involved people from affected communities in the solution, ensuring the revised system reflected diverse perspectives rather than just technical adjustments. Another powerful example comes from a financial services company that redesigned its loan approval algorithms after discovering patterns of unfair treatment. The team implemented what they called bias audits, regular systematic reviews of decision outcomes across different demographic groups. When disparities appeared, they didn't just tweak the algorithm, they examined the underlying assumptions built into their lending criteria. This deeper investigation revealed that some traditional financial metrics inadvertently disadvantaged people with non-traditional career paths, or those recovering from economic hardship. By expanding their definition of creditworthiness to include alternative data points, they created a fairer system that actually improved overall performance while reducing bias. These stories share common threads: committed leadership, diverse teams, willingness to acknowledge problems, and sustained effort beyond quick fixes. Change requires persistence, but these examples prove it's entirely achievable when organizations prioritize fairness alongside functionality. Empowering change: how to advocate for ethical AI. Understanding ethical principles. You don't need a computer science degree to participate in shaping how AI affects society. Most technology companies now publish AI ethics reports and model transparency statements. Reading these documents critically is itself an act of advocacy. When you encounter vague language about fairness without specific metrics, or promises of oversight without naming who provides it, you're identifying accountability gaps that matter. Contact companies directly when their AI systems affect you. Banks, healthcare providers, and insurance companies increasingly use automated decision-making. Ask specific questions. What data informed this decision? Can a human review it? What appeal process exists? Companies track these inquiries, and volume creates pressure for clearer explanations. Join or support organizations already doing this work. Groups like the Algorithmic Justice League, AI Now Institute, and Electronic Frontier Foundation need members, not just donors. These organizations provide accessible resources, explaining current policy debates, and offer template letters for contacting legislators about AI regulation. Algorithmic Justice League, ND, AI Now Institute, ND, Electronic Frontier Foundation, ND. Local engagement often proves more impactful than national efforts. School boards implementing AI-based student monitoring systems, city councils considering facial recognition for police departments, hospital networks evaluating diagnostic algorithms. These decisions happen in public meetings where your testimony carries weight. Opposing all AI isn't necessary. Asking the right questions changes outcomes. Who audited this system for bias? What happens when it makes mistakes? Which communities were consulted? Consumer choices signal priorities. When possible, choose services that explain their algorithmic decisions over those hiding behind proprietary secrecy. Support news organizations investigating AI harms. Share stories about both beneficial AI applications and documented failures. The most underutilized tool remains conversation. Discussing AI concerns with family, friends, and colleagues normalizes scrutiny and spreads information. Many people accept algorithmic decisions passively because they assume resistance requires expertise. Demonstrating that informed questions alone create accountability gives others permission to do the same. Identifying and addressing bias. Advocacy work doesn't follow a straight line, and that's fine. Most people interested in ethical AI don't wake up one day fluent in algorithmic terminology or confident testifying at city council meetings. You'll have moments of frustration, reading a company's ethics statement that sounds impressive until you realize it commits to nothing specific, or watching a decision maker nod through your testimony without seeming to absorb a word. Start where your knowledge actually is, not where you think it should be. If you understand that facial recognition systems struggle with darker skin tones, a bias extensively documented by the Gender Shades Study, which reported higher error rates for darker-skinned women in commercial systems, that single fact gives you standing to ask questions. Bulamwini and Gebru, 2018. You can inquire whether your local police department has tested its facial recognition vendor's accuracy across different demographic groups. You can ask your bank how it validates the fairness of its loan approval algorithms. These aren't abstract philosophical debates. They're practical questions about systems affecting real people. The power of diverse datasets becomes clear once you grasp how AI learns. Systems trained primarily on images of lighter-skinned individuals will naturally perform worse when encountering faces outside that narrow sample. The solution isn't mysterious, it's collecting training data that actually represents the full spectrum of people who will interact with the system. When you advocate for this principle, you're advocating for accuracy, not political correctness. Inclusive design practices mean involving affected communities before deployment, not after problems emerge. If your community plans to implement AI-powered traffic management, ask who participated in designing the system. Were disability advocates consulted about how it might affect pedestrians with mobility challenges? Did planners consider how changes might impact neighborhoods with limited alternative transportation? These questions don't require technical expertise. They require the life experience you already possess. Your voice matters because technology companies and policymakers often operate in echo chambers. They need perspectives from people who'll actually live with these systems, who understand community dynamics that don't show up in spreadsheets. You don't need permission to speak up about AI's impact on your life. Engaging with policymakers and communities. When you speak up about facial recognition accuracy or question an algorithm's fairness, you're exercising the same oversight citizens have always applied to powerful institutions. AI isn't different in this fundamental respect. It's another human creation that requires public accountability. The technical complexity doesn't diminish your right to ask hard questions about how these systems affect your community. Collective action changes outcomes in ways individual complaints cannot. A single person questioning a city's surveillance technology might get a polite dismissal, but coordinated efforts by advocacy organizations amplify public pressure. In 2019, San Francisco became the first U.S. city to ban its government agencies from using facial recognition technology, a landmark decision driven by extensive public advocacy from groups like the American Civil Liberties Union, ACLU. Such organizations achieve this by coordinating efforts, sharing research, and maintaining pressure over months rather than days. ACLU of Northern California, 2019. You've now seen how AI bias enters systems through flawed data and design choices, how it perpetuates real harm in hiring and healthcare and criminal justice, and how mitigation requires ongoing commitment rather than one-time fixes. You've also seen that people without computer science degrees are already influencing these discussions, because the most important questions about AI aren't technical. They're about values, what fairness means, whose perspectives matter when building systems that affect entire populations, whether efficiency should override privacy. These questions belong to everyone, and answering them shapes what AI becomes. But understanding AI's reflection of human values only addresses part of the picture. You might feel more confident about advocating for ethical systems, yet still wonder about the speed of AI development itself, whether the technology is advancing faster than our ability to guide it responsibly. That concern deserves direct examination, because it drives much of the anxiety surrounding artificial intelligence. The pace of change feels relentless, and that perception isn't unfounded.